When you factor a polynomial by grouping, you're going to separate the polynomial into two pieces. So I'm going to group the first two terms together and the last two terms together. When I divide it into two separate pieces, then I get to work with each piece independently of each other. So for my first two terms, I'm looking for the greatest common factor. Between 56 and 32, they both have an 8 in common. Variables with exponents, you're going to take the variable with the smaller exponent. In this case, we have m cubed and m squared, so I'm going to use m squared. Now, when you factor by the greatest common factor, what you're doing is you're applying the distributive property, but backwards. So I'm going to create a set of parentheses, and what goes inside the parentheses is what's left over when I divide each term by the greatest common factor. So 56 divided by 8 is 7. M cubed divided by m squared is m. Plus 32 divided by 8 is 4. And m squared divided by m squared is just 1, but we don't typically write the 1. Now I move to the second piece and I work with that. So between 35 and 20, I have a 5 in common. You always carry the sign in the middle with you. So now I'm going to divide each of these terms by 5. 35 divided by 5 is 7. There's nothing to divide the m, so I drag it along with me. And 20 divided by 5 is 4. When you get here, you have a new greatest common factor. I have 7m plus 4 and 7m plus 4. So I'm going to move the 7m plus 4 to the front of a set of parentheses. And when I divide each term by that 7m plus 4, the second set of parentheses is what's left over. So in number 2, I group my first two terms together, and I'm going to group my last two terms together, and I'm going to work with them separately. Between my first two terms, 35 and 21, I have a 7 in common, and between n cubed and n squared, I'm going to use the n squared. 35 divided by 7 is 5. N cubed divided by n squared is n. 21 divided by 7 is 3. And n squared divided by n squared is 1. Between 25 and 15, I have a 5 in common, and I always use the sign in the middle. So plus 5 times 25 divided by 5 is 5. There's nothing to divide the n, and 15 divided by 5 is plus 3. At this point, again, we have a new greatest common factor, 5n plus 3. So I'm going to move it to the front of new set of parentheses. And when I divide by 5n plus 3, my second set of parentheses is what's left over. In number 3, same process. I'm going to group my first two terms together and my last two terms together. When I group my first two terms together between 175 and 105, they have a 35 in common, and between x cubed and x squared, they have an x squared in common. 175 divided by 35 is 5, and x cubed divided by x squared is x. 105 divided by 35 is 3, and x squared divided by x squared is 1. In the second set, between 35 and 21, I have 7 in common, and I always use the sign in the middle. So 35 divided by 7 is 5, and there's nothing to divide the x. 21 divided by 7 is 3. I now have a new greatest common factor, which is 5x plus 3. So it's going to move to the front of a new set of parentheses. And when I divide both terms by 5x plus 3, my second set of parentheses is what's left over. But with this one, I'm not quite finished because this term still has a common factor left in it. So I need to factor out a 7 from each of these two terms. So I'm going to put a 7 all the way at the front. My 5x plus 3 still stays. And when I divide each of these terms by 7, I have 35 divided by 7 is 5, and there's nothing to divide the x squared. And 7 divided by 7 is plus 1. So you always have to make sure you don't still have any common factors to be factored out. One way to avoid the confusion is to look for the greatest common factor across all of your terms in the very beginning. So in number 4, I know that between 144, negative 90, 384, and 240, I have a 6 in common. So then I have 144 divided by 6 is 24x cubed minus 15x squared plus 64x minus 40. And I will drag my 6 all the way to the end so that I don't lose it along the way. But then this polynomial inside the parentheses, I will work with it the same way I've been factoring in numbers 1 through 3. So I group my first two terms together and my last two terms together, and I work with each piece independently. So between 24 and negative 15, I have a 3 in common, and they have an x squared in common. So 24 divided by 3 is 8, and x cubed divided by x squared is x. Negative 15 divided by 3 is negative 5, and x squared divided by x is 1. Between 24x cubed and 15x squared, I have a 3 in common. I also have an x squared. So 24 divided by 3 is 8. X cubed divided by x squared is x. Negative 15 divided by 3 is negative 5. And x squared divided by x squared is 1. In the second set, between 64 and 40, I have an 8 in common, and I always use the sign in the middle. So 64 divided by 8 is 8, and there's nothing to divide the x, and negative 40 divided by 8 is negative 5. And now I have a new greatest common factor, my 8x plus 5. So I put 8x minus 5 next to my 6. And when I divide both terms by 8x minus 5, my second set of parentheses is what's left over. In number 5, we have two variables that we're working with, but the process is still going to work the same. I'm going to group my first two terms together and my last two terms together and work with each piece separately. So between 15mn and 5m squared, I have a 5m in common. 15 divided by 5 is 3. Mn divided by n is just n. Negative 5 divided by 5 is negative 1. and m squared divided by m is m. Between 9 and -3, we have a 3 in common, and I always use the sign in the middle. So 9 divided by 3 is 3, and there's nothing to divide the n. -3 divided by 3 is -1, and there's nothing to divide the m. So we have a new greatest common factor, 3n minus m. So 3n minus m moves to the front. And when I divide each term by 3n minus m, my second set of parentheses is what's left over. And number 6, same song, little different dance. We're going to group our first 2 terms together and our last 2 terms together and work with each set separately. Between 4uv and 4u, I have a 4u in common. 4 divided by 4 is 1. U divided by u is u, and I carry the v. 4 divided by 4 is 1, and u divided by u is 1. Between 5 and 5, I have a 5 in common, and I always use the sign in the middle. So now I'm dividing each term by -5. -5 divided by -5 is 1, and I carry the v. -5 divided by -5 is +1. So now I have a new greatest common factor, which is v plus 1. So it's going to move to the front. And when I divide each term by v plus 1, my second set of parentheses is what's left over.